January 12, 1947. 03:20 hours. Pode Hole Pumping Station, South Holland District. William Thornton stood in the engine room watching the water level rise against the brick intake chamber while the twin Mirrlees diesel engines sat silent and cold. 54 years old, drainage engineer for 31 years. Superintendent of the Pode Hole Internal Drainage Board since 1938. Outside, the North Sea had pushed a storm surge up the Wash, combining with 3 days of heavy rain and snowmelt to flood 8,000 acres of black peat farmland across 6 parishes. The pumps could move 120 tons of water per minute. When running, they had been stopped for 14 hours. The fuel tanks were empty, and the nearest diesel supply was 40 miles away in Peterborough, with flooded roads between. The Lincolnshire Fens stretched across 170,000 acres of land that should not exist. Below sea level, below river level, below the water table itself. Held dry only by an intricate network of drainage channels, sluices, and pumping stations maintained not by central government but by 46 independent internal drainage boards. Each controlled by local parishes, each responsible for its own machinery, each operating its own pumps. The system dated to 1252, when Cistercian monks first cut ditches through the peat marshes. By 1947, the boards managed 3,200 miles of drainage channels, 180 pumping stations, and the livelihoods of 120,000 people farming soil that yielded the richest agricultural returns in Britain. But the boards operated independently. No central coordination, no shared fuel reserves, no mutual aid agreements. When one board's pumps failed, the neighboring parishes watched the water rise and protected their own land first. Thornton knew the history. The Pode Hole Board served 2,800 acres across the parishes of Pinchbeck, Spalding, and Surfleet. The pumping station, built in 1925, replaced windmills that had drained the land since 1732. 2 Mirrlees, K5 6 engines, 6 cylinders each, 150 brake horsepower, driving 2 48-inch centrifugal pumps through leather belt drives. The pumps lifted water 14 feet from the internal drain system up into the south 40-foot drain, which carried it north to the River Welland, which flowed east to the Wash. When the system worked, when fuel existed, when the North Sea cooperated. The storm had arrived on January 9th. Not exceptional by coastal standards. Time equals 400 milliseconds, but the timing was catastrophic. High tide at 0240 coincided with a spring tide and northwest winds pushing water into the Wash. The surge raised sea level 6 feet above prediction. Every river draining the fens backed up. The south 40-foot drain stopped flowing. Water accumulated in the internal drainage system. The pumps at Pode Hole ran continuously, fighting the rising level. Then, at 1840 on January 11th, the fuel tanks ran dry. Thornton had ordered diesel 3 days earlier. Standard protocol. The board maintained a contract with a supplier in Spalding who delivered 500 gallons every Monday. But the supplier's truck had broken down on January 8th. Replacement delivery promised for January 13th. The margin was acceptable under normal conditions. The storm eliminated the margin. By midnight on January 11th, the internal drain level had risen 4 feet. By 0300 on January 12th, water was flowing over the banks into the fields. Potato storage barns flooded first, then the lower pastures, then the roads. The board met at 0400 in the pump station's brick office building. 7 members, 3 farmers whose land was flooding, 2 representing parish councils, 1 from the local water company, Thornton as engineer, no authority to commandeer. Fuel, no ability to force neighboring boards to share supplies. No central emergency fund. The board's annual budget was £2,400, collected through drainage rates charged per acre. Fuel cost £140 per month. Maintenance, another £220. Wages for the 3 full-time pump operators, £480 annually. The reserve fund contained £180. A tank truck of diesel cost £75 and required authorization from the board chairman, who farmed 300 acres in Pinchbeck and was, at that moment, watching his winter wheat fields disappear under 18 inches of water. The decision came quickly. Send a truck to Peterborough. The main A16 road was flooded south of Spalding, but the A15 through Bourne remained passable. 40 miles each way. 4 hours if conditions held. Authorization for £150 emergency expenditure. Thornton's son drove. 23 years old, farm worker. Familiar with the roads, he left at 0445 in the board's Bedford truck, carrying authorization letters and cash. While the truck navigated flooded roads, the water kept rising. The Fens operated on a simple principle. Water flows downhill, but in the Fens, downhill meant up. The peat soil sat 10 feet below sea level in some areas. Rain falling on the fields could not flow naturally to the sea. Time equals 450 milliseconds greater than it required mechanical intervention. Pumps lifted it into higher drainage channels. Those channels carried it to rivers. The rivers, constrained by banks and sluices, directed it to the wash. When any component failed, the system collapsed. Other boards faced the same crisis. At Crowland, 8 miles west, the pumping station had flooded when the River Welland overtopped its banks. At Surfleet, 4 miles north, a bearing failure had stopped one pump. At Donington, 6 miles east, the diesel engines were running, but the south 40-foot drain was so full that pumping achieved nothing. The water had nowhere to go. Each board operated independently. The Crowland board served different parishes, collected different rates, maintained different equipment. No mechanism existed for coordinated response. The independence was deliberate. The internal drainage boards descended from the Court of Sewers, established by statute in 1531 during Henry VIII's reign. The courts had authority to compel landowners to maintain ditches, clear waterways, and fund drainage works. The system evolved through centuries of local control. Parliament passed the Land Drainage Act in 1930, formalizing the boards as statutory bodies with powers to levy rates. Time equals 300 milliseconds / employ staff and operate pumps. But the Act preserved local autonomy. Each board answered to its constituent parishes. Central government provided technical guidance through the catchment boards, but no operational control, no funding, no emergency authority. The arrangement worked during normal conditions. Local boards understood local drainage. Farmers who paid the rates served on the boards. Engineers knew every ditch, every culvert, every pump. Decisions happened quickly without bureaucratic delay. But the system had no resilience, no redundancy. When crisis exceeded a single board's capacity, the structure offered no solution. At 7:20, Thornton received a telephone call from the Pinchbeck Parish Council. Water was entering houses on Low Road, 8 families evacuating. The council requested immediate pumping. Thornton explained the situation. No fuel, no pumps, truck dispatched, 4 hours minimum. The council chairman asked about neighboring boards. Could Surfleet help? Could Spalding lend a pump? Thornton explained the reality. Surfleet was protecting its own parishes. Spalding's pumps were overwhelmed. The Moulton board, 3 miles south, had fuel, but their drainage area was also flooding, and their pumps were committed. No board had surplus capacity. No board had authority to abandon its own ratepayers to help others. The Bedford truck reached Peterborough at 8:40. The fuel depot opened at 900. The supplier needed cash in advance. Thornton's son paid £145 for 550 gallons. Loading took 20 minutes. The truck departed at 9:25, heavily laden, moving slowly on flooded roads. Estimated return time, 11:30 hours. By 1000 hours, the Podé Hole internal drainage system had risen another 2 feet. Water covered 4,200 acres. The flooding followed the topography of the peat. The lowest land flooded first. Fields that had been drained for 200 years returned to marsh. The peat itself was 12 feet deep in places, laid down over 4,000 years when the fens were tidal wetland. Beneath the peat, clay. Beneath the clay, at 30 feet depth, gravel and sand deposited by Ice Age rivers. The Romans had attempted to drain portions of the fens and failed. The medieval monks succeeded partially, but complete drainage required mechanical pumping, which arrived with steam engines in 1820 and diesel engines in 1920. The Bedford truck reached Spalding at 11:15, then the A16 north toward Podé Hole. Water over the road at 3 locations. The truck pushed through, engine laboring, diesel sloshing in the tank. At 11:45, it arrived at the pumping station. Unloading took 30 minutes. The fuel had to be transferred through hoses into the station's underground storage tanks. 550 gallons, enough for 48 hours of continuous pumping under normal conditions. Under current conditions, with maximum load fighting high water levels, perhaps 36 hours. The board would need another delivery by January 14th. At 12:20 hours, Thornton started the first Mirrlees engine. The 6-cylinder diesel turned over, caught, settled into a heavy rumble. He engaged the belt drive. The 48-inch pump began spinning. Water flowed from the internal drain up into the discharge channel, 60 tons per minute. At 12:30, he started the second engine. 120 tons per minute total. The water level in the intake chamber began dropping, slowly. 4 feet to recover. 8,000 acres draining through a single station. The pumps ran continuously for 28 hours. The storm surge receded on January 13th. The south 40-foot drain began flowing again. The river levels dropped. By January 14th at 1600 hours, the internal drainage system had returned to normal level. The pumps were shut down. The flood had damaged 4,200 acres of winter crops. 8 houses required repairs. 3 roads needed resurfacing. The Podé Hole Board calculated total damages at £18,000 across its district. The board's insurance covered £3,000. The remainder fell on individual landowners. The board meeting on January 20, 1947, addressed the crisis. 7 members present. Thornton delivered the engineering report. The system had functioned as designed. The pumps worked. The problem was fuel supply. The board needed larger storage tanks, currently 1,000-gallon capacity. Recommendation: expand to 3,000 gallons. Cost: £380. The board approved the expenditure, but the larger question remained unaddressed. What happened when multiple boards failed simultaneously? When regional flooding exceeded local capacity? The answer came 6 years later. The North Sea flood of January 31, 1953, killed 307 people on the British coast. The Lincolnshire Fens flooded across 90,000 acres. 23 pumping stations failed. The independent boards coordinated informally, but response remained chaotic. Engineers drove from station to station carrying fuel, parts, doughty hand and expertise. Farmers used tractors to rescue neighbors. Parish councils established evacuation centers. But no central authority existed to deploy resources systematically. Parliament responded with the Land Drainage Act of 1961. The Act created river authorities with oversight of catchment-wide drainage. The internal drainage boards continued operating, but under coordinated supervision. Emergency powers allowed authorities to redirect resources during crisis. The system became less independent and more resilient. The 46 Lincolnshire boards were consolidated into 28 by 1965. By 1990, only 12 remained, serving larger areas with shared equipment and mutual aid agreements. Podey Hole pumping station continued operating. The Mearley's engines were replaced in 1968 with electric pumps driven by 200 horsepower motors. The station was automated in 1987, no resident engineer. Remote monitoring from a central control facility. In Spalding, the old brick engine house remained, preserved as industrial heritage. The new pumps could move 180 tons per minute. The storage tanks held 5,000 gallons of backup diesel fuel for emergency generators. The system had redundancy. The parish-owned independence was gone, absorbed into regional coordination. William Thornton retired in 1963 after 47 years as a drainage engineer. He had worked through the transition from windmills to steam to diesel to electric. He had seen the Fens transform from independent parish fiefdoms into coordinated drainage districts. He died in 1971, age 78. His obituary in the Spalding Guardian noted his service during the 1947 floods and the 1953 disaster. It mentioned his advocacy for larger fuel tanks and emergency protocols. Local newspapers preserve small stories. The Lincolnshire Fens remain below sea level. 170,000 acres of farmland producing wheat, potatoes, vegetables, and tulips. The soil yields 800 million pounds in agricultural output annually. The drainage system now operates under the Witham 4th District Internal Drainage Board, the Black Sluice Internal Drainage Board, and the South Holland Internal Drainage Board. Together, they manage 180 pumping stations and 3,200 miles of channels. The pumps run continuously during wet seasons, fighting gravity and the North Sea. The system works because engineers learned from failure, because parishes accepted that independence had limits, because 307 deaths in 1953 proved that water does not respect administrative boundaries. The old parish-owned pumps are museum pieces now. The independence they represented, local control, local funding, local responsibility, disappeared into regional bureaucracy. Efficiency replaced autonomy. Coordination replaced isolation. The transformation was necessary. The Fens are dry because centralized systems plan for regional failure, not just local success. But something was lost. The boards that met in brick pump houses at 0400, spending their own money, protecting their own land, they owned the problem completely. Modern drainage boards operate with government grants, standardized equipment, and professional managers. More effective, less personal. If this story moved you the way it moved us, do me a favor. Hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about engineers fighting floods. Time equals 300 milliseconds / with empty fuel tanks. Real people, real decisions. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if your family farmed land below sea level. Just let us know you're here. Thank you for watching, and thank you for making sure William Thornton doesn't disappear into silence. These men deserve to be remembered, and you're helping make that happen.